This is take home number 4. We have 2 sets of data already somewhere. A list of colors from the M&Ms and a list of colors from the Smarties. And we're going to pick it up from this point on, so get your sheet in this order first. So we're supposed to identify our favorite color. Being near the Christmas season, I'm going to say my favorite color happens to be red. And then we're going to find the proportions here. So I need the proportions for M&Ms. And I need the proportions for Smarties. And overall. So first let's count. Column A, A2 through A200. Where it equals that word there. There are 21 of those. Likewise, oops, do the same here. Oh, grabbed the wrong thing. Okay, we have to change this. All right, so now we're going to count the nuns in B. So in B there were 18 that are red. I need the total for figuring the proportion. So now I need to count again. From A2 to A200. And likewise, I need to do that for the Smarties as well. So then I can figure the proportion. Just by taking the successes over the total count, and do that for Smarties as well. So I'm also supposed to find an overall proportion, so I need the total reds, that's this plus this, and the total count, this plus this, and the proportion there as well. Okay, on to step number 3. We have to do the inferential part of this. So I need a null hypothesis. In this case, my null hypothesis is going to be that the 2 proportions are the same. Not sample proportions, but overall proportions. So pi m equals pi Smartie. And I need to say what this means. So this means, and in here, I'm going to let you finish this on your own, but here you're going to talk about the fact that we're talking about population proportions, not just sample proportions. So you go ahead and finish typing that out. We're going to start with the alternate hypothesis. So H1. In this case, it's a two-sided. Two-sided means that now pi m does not equal pi s. And again, I'm going to let you fill in the rest of this with what that particular statement says about the proportion of red in these two candies. We set the alpha equal to 0.05. This means, again, I'm going to let you finish that, but you have to talk about what does it mean for a particular level of significance? What do you do with that number? How does it affect this test if that number is different, etc. So explain what choosing 5% means to you at this point. So this one, it says, why do we assume these data to be independent? So why should it be that the colors in this column are independent from the colors in this column? So you're going to go ahead and explain why that's true. We have to check for normal distribution. Normal distribution means I need to calculate a variance here. So let's see. We're going to do n times p hat times 1 minus p hat. And we're going to do n times p hat times 1 minus p hat. There. And then I'm going to let you finish typing up what it means for these two numbers to be like that and how that affects the test. Let's see, we need a test statistic. That's a z value, excuse me. And it is equal to the difference between this proportion, oops, forgot the equals, this proportion minus this proportion divided by the spread of that difference, which I know is equal to square root of the overall proportion times 1 minus that times 1 divided by this n plus 1 divided by this n. Yeah, finish that. Okay. So there's a z value. Now we need to calculate a p-value. So I'll be using the norm distribution on this particular value. Of course, if I do that, that just gives me a one-sided test. And I know this is a two-sided test, so I actually have to double that value. But if I look at that value, let's look at that value for a moment. That's a value from this value on down. But I need the opposite of that. I need from this value up. So it's not really that value. It's really 1 minus that value that I need. But then again, that has to be doubled. So I better start with 2 times that expression. And there we have a p-value. And now it says give a conclusion here. So we're going to give our conclusion. We're going to say something like reject HO because the p-value, and I'll let you finish that out, but this should be a full conclusion with context and everything else. Just keep going and typing and filling this in. All right, so I get a full conclusion here. And that finishes task number 1 and completes this video.